Hi everyone, welcome to UnoConf and this session where we're going to look at a new set of libraries, the Uno extensions, that will help you jumpstart the development process of your Uno application. I'm Nick Randolph and I'll be walking you through some of the extensions that we've been working on. For web developers, there's a standard recipe that includes dependency injection. That means when you create an API controller, you just specify the dependencies in your constructor and they're automatically injected when the controller is required. For mobile and desktop developers, there's no default equivalent, resulting in applications that are often poorly architected with strong coupling between views, view models, and services. Microsoft has extracted a number of the core capabilities out of ASP.NET and made it available via the Microsoft extensions. This covers hosting, logging, and configuration, to name a few. The Uno extensions are based on the Microsoft extensions and exposes a hosting model similar to what you'd find when building an ASP.NET application, through which services can be registered when the application starts and then subsequently resolved throughout the application. Today we're going to walk you through the Uno extensions from creating a host and registering services through to using the navigation extensions to navigate between pages, views, and the application. At the core of the Uno extensions is the instance of the iHost, which exposes the dependency injection container and the methods to start and stop the application. Application services are registered when the application starts through the iHost builder interface. Service instances can subsequently be retrieved throughout the application. The Uno extensions needs to be registered with the iHost builder and are subsequently exposed throughout the application via the iHost. This all sounds very theoretical, so let's jump in and take a look at some of the code. We're going to start with a basic application that creates a frame and navigates to a login page. This is very similar to most UWP, WinUI, and Uno-based applications. Our design team has already provided us with the various XAML pages, so all we need to do is wire up the application logic. We're going to actually start by creating an instance of the iHost. We're going to follow the standard pattern for creating the iHost instance, which consists of creating an iHost builder, and by calling the create default builder method, and then invoking the build method to return the iHost. At this point, we can already start to query information about the host. For example, the iHost exposes application name, the content folder for loading files packed with the application, and the name of the current environment. Let's go ahead and try and retrieve the environment name and display it to the output window. Let's just set a breakpoint, and now we can go ahead and run our application. What's happening here is that we're going to retrieve an instance of the iHost environment interface that will provide us the information we need about our running environment. So if we hover over here, we can see this is set to production. The environment can be changed. For example, when you're debugging the application, you may want to go ahead and set the environment to development. This might drive different application logic, such as more log output or using a different input for loading data. We'll come back up here, and we're going to protect this using the hashif debug and set the environment to development. Let's go ahead and run our application again. Now when we hover over here, what we should see is that this is now set to development. The default iHost implementation doesn't provide much more than the basic services required for dependency injection, loading configuration, and setting up logging. We'll come back to configuration and logging in a minute, but let's first see how we can register some of the services that our application will be using. Again, we're going to come back up to here where we're setting up our iHost, and we're going to go ahead and register some services. So here we can see that we're registering the product services class for the interface iProduct services. Now when we want to retrieve our list of products, we can retrieve an instance of the iProduct service and go ahead and query it, for example, passing a search term for, say, shoes. Let's come back down to our application and enter this code. to retrieve the iProduct service and then query using the getProducts method for the search term of shoes. And we can see the return value here gives us a length of 3. So 3 shoes were listed returned from the products. The host builder has already set up logging into the application. However, Uno Extensions provides additional support for adjusting the log level, enabling logging for the Uno internals, as well as using Serilog for more configurable logging. For example, being able to log to a file. Let's go ahead and actually enable platform-specific logging and set the minimum log level for our application. Again, we'll return back to our iHost up here and drop in some code. So here we're enabling logging, and then we're setting the minimum log level to error. Let's go back down and actually adjust our code that we had earlier so that instead of writing to the debug output, we're actually going to make use of our logging. So we'll change this code. It's the same code, except this time we're retrieving an instance of the iLogger interface, and we're going to use that to log out messages. Let's go ahead and set a breakpoint. We'll run this application up. And we can see at this point, despite writing logout information here, we switch the output window, we're not actually seeing any output. This is because our minimum log level is currently set to error. Let's go ahead and change this to information. And we're going to run our application again. And what we should see now in our output window is that we can see that the development environment has been returned here. Notice here that we're also seeing the method that the log command was executed from. This provides us some additional debug information that's quite useful. The next thing we're going to look at is configuration. What makes it possible to add applications.json files as configuration sources. It also supports environment-specific application settings. For example, appsettings.development.json. It also includes supporting JSON files as either content or embedded resource files. Configuration supports accessing configuration sections by either associating a section with a particular class. An instance of the register class can then be retrieved throughout the application. Let's go ahead and register the appinfo class. So we'll come back up here and specify the appinfo class. We can go ahead and retrieve this information later. And in this code, we can see that we're retrieving the instance of the appinfo, and we're going to use that to set the title on our application. Let's go ahead and run this. If we hover over here, we should see that this is now set to the UnoConf app/dev. And the reason for this is that we have two app settings files. We've got appsettings.json, where we've got the title set to UnoConf app, or Commerce app, and then we've got the appsettings.development.json, where it's got the dev suffix. We can see here that because we're running in development mode, this file has taken precedence and is overriding the value set in the default appsettings.json. Configuration also supports writing application-specific settings, which can be made use of by the same mechanism as other configuration information. To make use of a configuration section that's writable, we just need to register the class with use settings instead of use configuration. Come back here and we're going to register a different class as settings. Here we can see that we can make use of the commerce settings, and we're going to be able to use that to persist the last search term that we entered. So let's come back down to our code, down here, and we're going to retrieve a writable options version of the commerce settings, and we're going to use that to specify the last search term. Elsewhere in our application, we can then retrieve this using the same mechanism as we would any other configuration information. So we can specify that here. If we run this up now, we'll see that this last search term is set to the persisted value of shoes. And this will be persisted through different application instances. And we can see that that is set to the value of shoes. The last Uno extension we're going to cover today is navigation, which is probably one of the hardest challenges in any XAML-based application. Out of the box, the platform supports view-to-view style navigation, for example, being able to navigate to a new page in a frame. Other frameworks build on top of this and provide a level of abstraction, such as view-to-view navigation, or simple URI-based navigation scheme. Navigation in the Uno extensions aims to provide a consistent model for navigation that can be accessed from the view model, or even XAML code. The other challenge is that whilst navigation appears to be quite simple, for example, just simply navigating from one page to the next, it's made difficult by the wide array of permutations that need to be supported. For example, navigating to request a value, or navigating between tabs. Navigation is also more than simply navigating forward to a new page or to a different tab. In some cases, it may be necessary to navigate back to a previous view. For example, navigating to the previous page in the context of frame-based navigation. Navigation also needs to support being able to pass values or data between views. There are also scenarios where navigation needs to support selecting or picking a value that's returned to the caller. We took on these challenges and aimed to provide a simple yet consistent model for navigation, whilst also supporting the wider variety of scenarios that are required for a typical application. Our approach to navigation is that an application can be broken down into a series of navigation regions. For example, a frame would be a navigation region. Regions can be nested, for example, having tabs nested within a page that belong to a frame. Note, in this case, the tabs and frame would be navigation regions, but the individual tab items or pages would not. Tab items and pages just represent the current route that has been navigated to for a particular region. Each region has an associated implementation of the iNavigator interface, which understands how navigation should be applied to a particular region. For example, navigation on a frame translates to simply calling the navigate method on a frame itself, which displays the new page, typically moving the existing page to the backstack. For tabs, navigation translates to switching between the tab items. At the heart of navigation in the Uno extensions is the navigate method on the iNavigator interface, which accepts a navigation request that includes the route to navigate to. The iNavigator implementation understands how to translate a route to the specific implementation for a region type. This all sounds way too theoretical, so let's just see it in action. We're going to start by enabling navigation again back on our iHost. So let's come up here and enable iNavigation. We then need to go down and replace the existing navigation logic, so creating a frame, navigating to the login page, with the code that will actually use the iNavigate pattern. So we'll go here, and this essentially sets the content of the window to be a shell view control, which we'll see in a second, and enables it for navigation. You can think of the shell view control as basically being the top level view of the application and contains the first navigation region. In this case, it's going to be a frame. But the thing to note about the shell view is that it's simply just a user control. You can call it whatever you like. There's no logic tied to the name shell view. The only special thing is that it contains a frame where the region.attach property is set to true. If we look at the code behind, you'll notice that there's nothing special there. The only question that might come to mind now is, okay, well, where do we put the logic for navigating to our first page of the application? You know, where's the standard logic to navigate to, or call navigate on the frame? This is all done within the shell view model. An instance of the shell view model is created at runtime and set as a data context for the shell view. You can see the logic here isn't very advanced. All we're doing here is actually logging out the fact that the application starts. So if I run the application now, all we're going to see is a blank page. What we need to do is actually change this to take a dependency on the iNavigator interface and then use that to navigate to the first page within our application. So let's go ahead and do that. So we can see it's taking a dependency on the iNavigator interface, and we're going to use that to navigate by view model to our login view model. Let's go ahead and run the application now. And we can see that we're now going to the login page. However, if I start to type the login in here and hit the login button, it's not going to go anywhere. And that's because in our code here, we're waiting for navigation to complete, i.e. we're awaiting it. And all we're doing here is waiting for it to navigate to the first page. We're not actually waiting for a response back from that page. So let's just change this logic slightly. And this time, in addition to waiting for the navigation to complete, we're then going to await the result. We're then going to validate that the result is actually a credentials object and make sure that we have a valid username. Once we do that, we're then going to navigate onto the home view model, which will take us to the home page of our application. So let's actually go ahead and run our application and check that we can now log in. Now we can log in and we're taken to the home page of our application. If I go to the profile tab, all that, and hit the logout button, you'll notice that again, it's not logging out for us, so the navigation is not actually doing anything. So if we come back to our show view model, we can update this logic again, and this time await the result from the navigation to the login to the home view model. So we can go ahead and run this application up now. Let's restart this. And you'll notice here that when we're awaiting the result of the navigation to the home view model, we don't care about the response because we're just assuming that by the time this returns, we're actually logged out of the application. So all we want to do really is actually call the start method again and perform the login function. So log out, and now we can log back into our application. Okay, so this is typical logic that you'd imagine in an application. The only thing that we probably would add in a real world application is that in the startup logic, we would actually check to see whether we've got a persisted set of credentials, and thereby the user wouldn't have to log in every time they enter the application. Okay, the other thing that I want to just quickly show is another type of navigation. And so if we click on this filters button, we're seeing that we're navigating to this pop-up dialog. We can specify a filter and hit the apply button, and then that data is then returned back to our application. This is an interesting example because it actually demonstrates being able to navigate using XAML. So if we come down on our products page to the button for filter, which is right here, we can see that the hyperlink button, the navigation here is defined completely in XAML. And so we're specifying that we're going to navigate to the filter dialog, and the dialog is specified by the exclamation point. And we're going to pass in a data object. In this case, it's the existing filter value that's being applied to the products list. Similarly, if we go to the filter pop-up page and we come down and look at the apply button, we can again see that the navigation request is defined in XAML. This is a back navigation or closed navigation. Again, the data is specified to be the updated filter value that's specified in the filter pop-up. Okay, so this is an example of a complete round trip of XAML-based navigation without us having to write any code behind. As we can see, navigation is quite a complex topic when you look at all of the different types of navigation controls. For example, frames, dialogues, tabs, pickers, and all the different navigation patterns that need to exist, such as view to view or view model to view model, or even XAML-based navigation. The Uno extension's navigation model provides a consistent model where the navigation model is the same whether you're invoking it from the view model, or XAML layer. It's also extensible, meaning that implementations can be added for different navigation controls. There are some other Uno extensions that we haven't covered today. For example, defining and registering HTTP and refit endpoints, and for example, localization support throughout the application. In this session, we've stepped through a number of the Uno extensions that can help reduce the overhead of building an amazing Uno application. Thanks for watching this session, and feel free to send any feedback to this session or the direction that we're heading with the Uno extensions. Thanks, everyone.